It is a great day and happy to have you children. Let us start this academic year with lots of hope and let it be a wonderful and successful academic year for all of us. Today we are going to start it with a very interesting lesson, electrostatics, which speaks about the stationary electric charges. Have you ever heard about the Tamil quote, "Andathil ullathe pindathil undu, pindathil ullathe andathilum undu"? Actually here the word pindam represents the human body and the word andam represents the universe. The study of human body along with the other beings and plant kingdom is termed as life science, and the study of universe is called physical science. And you know very well, chemistry look into it with a different perception, and the meaning of the Greek word physics is nature, and yes, it speaks about the nature and it has been trying to explore the universe around it. And now you may be wondering in what way human body is connected to the universe. Think over it and you will be fascinated. Maybe we will discuss about in the videos to come if time permits. Now we can pass on to our first lesson, electrostatics. But as it is our first class, I just want to introduce you into our first volume 2. Here is the list of lessons in volume 1, and here all the 5 lessons are very much closely connected to each other. The first lesson, as you see in the list, speaks about the electrostatics, and it speaks about the charges at rest, just like how we are forced to stay at rest inside our home because of this corona issue. And the second lesson speaks about current electricity, that speaks about the charges that flow, just like how badly we want to come out of the houses now. Then the third lesson speaks about magnetism and the magnetic effects of electric current. So it speaks about the consequences of moving charges, that is current. Just like how our government and media has been speaking about the consequences of this coming out. Lesson 4 speaks about electromagnetic induction, that explains how current can be produced by varying magnetic field. And it also speaks about alternating current, that is AC. And lesson 5 speaks about the electromagnetic waves which are produced by accelerated electric charges. So on the whole, the first volume explains about different ideas related to electric charges. So children, I want you to understand how much it is important for you to be clear with the ideas explained in each and every lesson, as that will help you to understand the next one better. Now when speaking about the second volume, there we will be speaking about the advanced physics and the different technological developments of physics. Okay, now our first lesson, electrostatics. So this can be divided into two words, electro and statics. Electro represents electric charges and statics means stationary, that means at rest. So electrostatics speaks about the electric charges at rest. At this juncture, I want you to recall what you had studied in your 11th standard as the different branches of mechanics. Do you remember? Statics and dynamics. Even there, static represents the same thing, that is the study of objects at rest. Fine. Now look at this diagram. You can understand what it is speaking about in the first glance itself. It speaks about how the electric current converts a conductor into a magnetic material. And it speaks about electromagnetism, a reason for all the scientific advancements we have today, and that makes us to understand the importance of studying about electric charges and of course the electromagnetic force. Now I want you to recall the 4 fundamental forces of nature. Can you name them, children? We have studied in our 11th standard, right? Yes, I know you might remember it definitely. They are gravitational force, electromagnetic force, weak nuclear force and strong nuclear force, right? Good. So we might have learned all these. Recent theories have proved that except the gravitational force, all the other forces are nothing but the forces arise due to the electromagnetic forces within the atom. So please note it down. The different forces like tension, friction, normal force, everything comes under this category. So you may little bit wonder how all these are interconnected, right? So let us see few examples of electromagnetic force, children, so that you will understand the concept even more better. So look at this picture, the one in the left. You can see a man pushing the car, right? And here the interaction happens because of the atoms in his hand and the atoms in the car. Similarly, look at the picture in the right side. Here the man is standing on the earth's surface and he wonders how it is possible. So as you know, it is just because of gravitational force, but that alone is not the end of the story. Here there is a normal force acting in the upward direction just to counterbalance the downward gravitational force. And please understand, the reason for this normal force is the interaction between the atoms in the earth's surface and the feet of the person. So these two examples explain how the electromagnetic force between the atoms is the reason for every force and responsible for keeping everything in control. So I just want to summarize what we have discussed so far. We have discussed about what is electrostatics and how all the forces except gravitational forces are arising due to interaction of atoms. We have two more topics left for today: the historical background of charges and the properties of electric charges. These two questions can be expected in 3 marks, children, so please make a note of it. So the first one to be discussed is historical background of electric charges. So Greeks were the first to get some ideas regarding charges. So Thales in the year 600 BC found out that amber, one of the gemstones, can attract small bits of leaves when it is rubbed with animal fur. It was fascinating for them, but what they thought was it is just a property of amber alone, and it is same as how magnet attracts magnetic materials. So you can see here the picture of the amber is given here for you. Later, only in the year 1700 AC, William Gilbert proved that it is not just amber, even other objects also possess the same property of attracting specific things when they are rubbed against other specific objects. So this kindled their curiosity, and from the exploration they could understand the objects gets charged when they are rubbed against another objects. So listen carefully, children. Now we have come to the important point of our discussion. To understand it even more better, I want you to picturize what is happening here. As we all know, the subatomic particles are proton, electron and neutron. As we know, protons are positively charged, electrons are negatively charged, and the neutrons are neutrally charged, that is, they are chargeless. Any atom in its normal ground state has equal number of protons and electrons. So for example, if you consider helium atom, it has 2 protons and 2 electrons. So plus 2 minus 2 is equal to 0. Yeah, simple maths. It makes us to understand that they are neutrally charged, that is, atoms are neutrally charged in the normal state. So now when it is rubbed against another object, for example, if a glass rod is rubbed with a silk cloth, what happens here? So what happens here is the transfer of free electrons from glass to silk. So here, as you guess, glass is losing the electrons and it becomes positive, just like how we become more positive person when we give up a negative character, right? And the silk becomes negative as it gains electrons here. So same thing happens when amber is rubbed with fur. Amber becomes negative and fur becomes positive. Can you guess the direction of the transfer of electrons now? Yes, it is from fur to amber. So this explains why the word electron is coined from the Greek word electron, which means amper. Here, this current produced because of friction is called frictional electricity, and the current due to these static charges is called static electricity. So next slide explains about an experiment that was performed to understand the charges better. A charged rubber rod is brought closer to another charged rubber rod, and you can see that they repel each other. And at the same time, you can see that if you bring another glass rod closer to the rubber rod, they both attract each other. So this particular experiment makes them to understand 3 important things, which is explained in the next slide. So as you see here, we understand the existence of 2 charges, positive and negative. Okay, so please make a note of it, positive and negative. So next we understand the charging of the rubber rod and glass rod are not one and same, because here glass becomes positively charged when rubbed with silk, but emanite become negatively charged when rubbed against fur. So here the second and third points are very familiar to you. Just like how we speak about the magnetic poles, here like charges repel each other, unlike charges attract each other. Okay, so now I want you to introduce you to new term, triboelectric charging, which is nothing but charging of objects through rubbing. So please note down, children, this is another expected 2-mark question. So triboelectric charging is nothing but the charging of objects through rubbing. Now let us pass on to the last part of our today's discussion, properties of electric charges. So there are 3 properties of charges as it is listed out here. The first point explains the definition of electric charge, the second point explains the conservation of charges, and the third point explains about the magnitude of charges. Let us discuss about them one by one. So in the first point, charge is called as the fundamental and intrinsic property of particles, just like mass is the inherent property of atoms. Can you guess the reason, children? The reason is electrons have a negative charge, protons have a positive charge, and neutrons are chargeless. Everything else that is around us, whatever it is, made up of protons, electrons and neutrons, they also have electric charge, and that is the reason charge is called as the fundamental nature of particle, as they make up everything and they are the building blocks, just like how cell is the building block of all of us. So that is about the first property. The second property is nothing but the conservation of electric charges, and it is same as the conservation of mass and energy. You might have studied about conservation of mass and conservation of energy, right? It is same as that. So this is the actual law, and what we have to understand from this is, in a physical process, always net change in the charge is 0, and also the total charge of the universe is always a constant. I think you might not have any difficulties in understanding first 2 points. Now let us move on to the third point. It speaks about the quantization of electric charges. In order to understand that, first of all you have to understand what is the meaning of quantum. Quantum means discrete or digital, that means not continuous. So to understand it better, I want you to think about the difference between an analog and digital watch. In an analog watch, the time can be set perfectly at any moment with the hour, minute, second as 5 hours, 30 minutes, 20 seconds. But when we speak about digital watches which we wear, some information may be lacking here, like 5 hours 30 minutes. After 1 minute we can say 5 hours 31 minutes, and you can see that this is not continuous, and it won't take all the possible values between 5:30 and 5:31. Okay, fine. I know some of you, those who are still awake, might have got a question in your mind about the availability of digital watches in the market nowadays, which even shows seconds. Yeah, I agree, but initially the digital watches were designed in that manner without showing seconds, and that is why it was named in that manner. Okay, children. Okay, so analog means continuous, that is, it can take all the possible values, and digital means discrete, that is not continuous, it can take only discrete values, selective values, not all the values. So here charges are said to be quantized. I repeat, not quarantined, they are quantized. That means the charge of any object is equal to the integral multiple of fundamental charges, that is fundamental unit of electric charge, that is Q is equal to Ne. Here the value of E is nothing but the charge of the electron, and that is equal to 1.6 into 10 power minus 19 coulomb, and remember the unit of charge is coulomb. So to understand it better, imagine a ball with 1 electron. It will have 1 E amount of charge totally, and if it has 2 electrons, it will be having 2 E charges totally. So on generalizing it, we can understand if it has n electrons, it will be having Ne charges totally, and that is how we have got the formula Q is equal to Ne. So now let us see why it is called as quantization here. Here the charges can take only integer values, that is n, and it cannot take fractional values, that is 1.5 or 2.5 charges are not at all possible, and that is why it is said to be quantized. Got it, children? So that is all about the properties of electric charges. So today I think you would have got a clear picture about electrostatic charges, their historical background, types of charges, triboelectric charging, and finally about the properties of charges. So I just want to like to conclude with a quote which I love the most, children. Motion of electric charges creates electric current, as like the motion of our hopes and dreams creates success in life. And of course, that is what keeps us going. Let us keep our hopes high, children. Thank you. Thank you so much.